Hey everyone, today we're going to be working through IXL assignment 9CP, prime factorization. Before we get started, let's go through some vocabulary words. So first off is what is a factor? Because if we're doing prime factorization, we kind of need to know what a factor is. Well, a factor are the numbers that are multiplied together to receive our answer, to receive our product. So if we look here on the left, 2 times 3 is 6. Well, 2 and 3, those are considered the factors. Our factors are those two numbers that are being multiplied together. And we can kind of think of that as our little factor ninja because we are chopping up our numbers into smaller pieces. So if we want to know our factors of 16, that would be 1 and 16 because 1 times 16 is 16. And then 2 and 8 would also be factors because 2 times 8 is 16 and 4 times 4. So 4 would be a factor because 4 times 4 is 16. So our factors are the numbers that multiply together to receive our product, to receive our answer. All right, well, if we're going to be doing prime factorization, that's great. We know what our factors are. But what are our primes? Our primes are a number where its only factors are 1 and itself. So, for example, you can see not all of them, but all of them 1 through 100 on the left on this chart. But if we look at some of the more common ones, 2 is a prime number because the only things that multiply together to equal 2 are 1 and 2. Same for 3. Only factors are 1 and 3. Same for 5. So that prime is a number where the only factors are 1 in itself. All these other numbers that are not considered prime, they are called composites because they are composed of many factors. So that's all of our other numbers. That's, a pretty big majority of them. They're listed here in pink. But 4 would be composite because it has multiple factors because we can do 1 times 4 and we can do 2 times 2. 6 would be a composite number because we have 1 times 6, but we also have 2 times 3. So there are multiple factors that make up that number. All right, let's now switch over to IXL so we can practice factoring these numbers down into just its primes, doing that prime factorization. All right, guys, here we are on IXL. You can see that we're on assignment 9CP, prime factorization. A couple of quick reminders is if you need to see some more examples after this video, IXL has a video that you can watch, or you can even open this up and click that drop down and you can see an example like you would in a textbook. Okay, let's get started. So we want to know what is the prime factorization of work. When you're working with doing prime factorization, there's more than one way that you can organize your work, but the most common way is by making a factor tree. And note that you are able to write straight on the IXL screen if you wish, or of course you could have, a piece of paper and a pencil side by side, but right here is a little pencil that you can click on and you can write on the IXL screen if you wish. So if we want to find the prime factorization of 4, we need to break this down into factors. We can go ahead and start off with our first factor that we can think of. Well, we could do 1 times 4. That doesn't really change anything. So what would be another? Break that down any further. 2 are prime numbers. So we actually have mostly completed our prime factorization because when we deal with our primes, it is simply just the numbers that are left over. We're breaking it down simply into its primes. Therefore, our prime factorization would be 2 times 2. All right, let's see, what is our prime factorization of 10? You guys might be able to, on some of these numbers, find the answer a little bit differently, but I want to keep showing you that factor tree because that'll really be helpful as our number gets larger. So if we want to break down 10, we need to come up with our first pair of numbers, our first set of factors that are going to multiply to equal 10. First thing that comes to mind for me is 2 times 5. Now you look at those numbers, and if they're prime, you're done. If we have a composite number, we're not done. Well, 2 is prime because the only thing that you can multiply to get 2 is 1 times itself. And 5 is also prime because the only thing we can multiply to get 5 is 1 and 5. So another quick one. 2 times 5 is our prime factorization. I forgot to actually accidentally click it, which is really good. So if you ever forget to answer, it will remind you to save you before you get it wrong. All right, let's do this one. 16, we have a little bit larger of a number. We might have a little bit more going on here. So when you start off with your factor tree here, you can pick any 2 factors, so any 2 numbers that multiply to equal 16. First ones I think of are 2 times 8. That's what I'm going to start with. 2 times 8. All right, 2, that's a prime number, but 8, that's a composite. I can keep breaking 8 down. So what 2 numbers multiply to equal 8? Well, 2 times 4. And then what multiplies to equal 4? Well, 2 times 2. Now all I have left are my prime numbers here. So we have 2 times 2 times 2 times 2. So 1, 2, 3, 4 2s. So if we look at our answer choices here, that would be this one. You have 1, 2, 3, 4 2s. And you could always double check your work by multiplying that back out. If you multiplied 2 times 2 times 2 times 2, you would get the answer of 16. And because they're all primes, know that that's the correct answer. All right, let's try just a couple more. What about the prime factorization of 5? Is 5 already a prime number? Because the only things that multiply to equal 5 are 1 in itself. So therefore, when you get a prime number, that number itself is the prime factorization. All we are left with is that 5. All right, once you get a little higher in the score, you are going to have to write out prime factorization yourself instead of choosing it. Notice that the directions tell you to order those factors from least to greatest. So let's go ahead and make our factor tree, find our prime factorization of 49. And it doesn't matter what you start with, just what are the first 2 factors that you think of that equal 49? For me, it would be 7 times 7. Well, now when we look at those 7 and 7, are those prime or composites? 7's a prime number because the only 2 factors that multiply to equal 7 are 1 and 7. Therefore, our answer here is 7 times 7. That's our prime factorization. Now, I do want to show you a little trick on the next problem in case, you get to a number that's larger and you're not, quite sure of the, numbers that multiply to equal. If you're having a hard time thinking of that, I'll show you a strategy to do that on the next one. I know sometimes as our numbers get larger, that can happen. And notice that I didn't even have to put any spaces there and it still counted as correct. All right, let's do one more. And I know that 18 isn't a super large number, but I still want to show you the strategy that I was referring to. So if we need to break down 18 and you are having a very difficult time thinking of what two factors are that multiply to equal that, well, you can kind of start just going through your list. You can say, okay, is 18 divisible by 2? Or you could think of it as 2 times what is 18? Well, in this case, that works. 2 times 9 is 18. So we could start our factor tree that way. Or if you didn't know that, you could say, okay, say 2 didn't work, or you didn't think of, 2 times 9 is 18. Go to the next number, 3. You can either look at it backwards and say, okay, 18 divided by 3, does that work? Do I get an answer? Or you can think of it as 3 times what is 18? Well, 3 times 6 is 18. So you could start it off that way. And you can keep going. So if you have a larger number, just start working through. Say, is 2 times something going to give me that? 3 times something, 4 times something, 5 times something. Just go through your list there, and you can either think of it as multiplication, or because multiplication and division are opposites, they're related, you can do that backwards thinking. All right, let's work out this factor tree both ways so we can, finally prove, I've kind of talked about it, that it doesn't matter what set of factors you start with, you're going to get the same answer. So if we look over here in red, we have 2 and 9. 2 is a prime, can't break that down anymore, but 9 is composite. 9 breaks down into 3 times 3, giving us our primes here. And if we put them in order from least to greatest, of 2 times 3 times 3. Now, if we look over in blue, let's say you started with 3 and 6. Well, 3 is prime, so that one's a dead end. But 6 is not. 6 can break down into 2 times 3. And once again, we only are left with primes. So if we put those in order from least to greatest, it is the exact same answer. And if you wanted to check your work, you can multiply that back out, and you would get 18. 2 times 3 is 6. 6 times 3 is 18. And then when you type it in, make sure that you put it in order from least to greatest, and it doesn't matter whether you put spaces or not, it'll still count it as correct. All right, I hope this video helped. It is now your turn to try it out. If you have any questions, make sure to email your teacher or come to a help session.